Hello again. Now in section 3.3, we're going to look at the idea of higher derivatives. And the overarching theme here is that these are going to be derivatives of derivatives. Surprise. Okay, so it's a derivative of something that is already a derivative itself. So to put that in notation here, f of x is a function, all right, our original function, and we can take its derivative. We've been doing that all section here, all chapter even. So we can take its derivative to get a new function called f prime of x, okay? And yes, f prime of x is a function itself. And we can take the derivative of that function. So we can take its derivative too. All right. So let's look at some notation for these here. We're going to just do derivatives with respect to x, and we're going to start with the original function f of x. So we could say, taking the derivative with respect to x of f of x gives us f prime of x. All right, we've seen that. Now, if you do it again, if you do the derivative process on f prime of x, so taking the derivative with respect to x of f prime of x, that is going to look like f double prime of x. So you get two of those little prime symbols there in the Newton notation. And we call this the second derivative. Okay, second derivative of that original function f of x, because we have taken the derivative of that original function twice now. Okay, and this is in Newton notation. Newton's notation. So just a little note here, Leibniz's notation for this looks a little bit interesting. Okay, in Leibniz notation, we'd be taking d dx, and then usually for that Leibniz notation, we call our function y. So the derivative looked like this, dy dx. All right. And so what the Leibniz notation is for the second derivative is, looks like this, d squared y over dx squared. Okay, so just for notation purposes, you can remember that because there's two d's up here, so there's like the d squared type of thing going on, and then down here there's dx and another dx, so you can think of that being like the dx squared part. Yeah, maybe don't focus too much on that. That's just kind of helping you remember the notation. Okay. But we'll stick to Newton's notation for right now here. So there's the second derivative, f double prime. And, you know, when we take the derivative of a function, it just gives us another new function. So f double prime is a function itself. And we could take its derivative too, as long as it's still differentiable. And when we do that, we get f triple prime of x. And this, as you might guess, this is called the third derivative of f of x. Okay, third derivative, triple prime. And, you know, that's a function too. So we could take its derivative again. All right. And you can see we are going to start being able to do this indefinitely. okay? And when we do this, the derivative of f triple prime, I mean, you could put f quadruple prime, but at this stage, you don't want to be counting too many of these little tick mark things, too many of those prime symbols. So the notation switches at this stage usually. And instead of 4 little prime tick marks, we put a little 4 in parentheses up in the exponent. And that is the 4th derivative. And I did say up in the exponent area there, or up in the exponent, that is not actually an exponent. Let's make a big note of that for this 4th derivative of f of x, that this right here, that's not an exponent. This is not f to the 4th power. This is the 4th derivative. It's just up in the, that's called the superscript area where exponents would normally go. But when it's in parentheses like that, that's how you're going to tell that this is actually a derivative. So this is different notation. And make yourself a little note that this is not an exponent. Because, yeah, that could really mess things up if you mistake the two of those. Okay, so if you keep doing this indefinitely, let's say you could do this n times over and over again, you could get the nth derivative of f of x. Okay, so this is f with a little parentheses n up in the superscript there. That's what happens when you take the derivative n different times. And sometimes you do have to use this generically in certain problems. This is the nth derivative of the function f of x. All right. And it is worth noting that in here, notice how we are just counting first derivative. Oh, that would be this one right here. We didn't label it as such. This is the first derivative. We've just been calling it the derivative generically, but truth be told, it's just the first of many potential derivatives here. Okay, so it goes first, second, third. Notice that there's not like a 3.5th derivative or something. We are counting in terms of positive integers here. So the nth derivative in is a positive integer. You can't take like the negative second derivative of something. We'll kind of get to what the opposite of a derivative is later on this semester, but n has to be a positive integer here, so you're counting through first, second, third, fourth, up to nth derivative. Okay, now in the next video, we'll do a little example.